Hi, I'm Alan Ross. I'm the managing editor of APC Technologies. We are at the IEEE PES Grid Edge Conference, one of the sponsors of these interviews. And our other sponsors are Dynamic Ratings and H2 Scan. Enjoy these interviews. My next guest is Colin Gerber. Colin is in charge of sales for Pfiffner. I have a hard time saying it.
Pfiffner,
out of Zurich, right? The company's out of Zurich, right? But you're in the head of North American sales or U.S.?
North America.
North America.
U.S. and Canada. Yeah.
Okay, yeah. When many people say U.S. and they mean U.S. and Canada, I grew up in Canada, so really? I always have to make sure that we say Canada. Tell me a little bit about your background. How did you get into the power industry, and how did you get into Pfiffner?
Well, I was 14. I started my apprenticeship with Pfiffner.
Are you serious? At 14?
At 14,
oh,
yeah.
Wow.
That's usual in Switzerland. So you finish your school, and then you can either go to like high school or you make an apprenticeship, and at the same time you can still go to like high school. So you have 2 days a week of school and 3 days a week of working and like training at work. So I did that. It took 3 years. I went through all the different departments at Pfiffner, like purchasing, accounting, sales, and I ended up in sales at the end, yeah. And then I started in inside sales, and now I'm responsible in outside sales.
It's a lot better being in sales than it is to be in accounting, okay? I just want you to know
yeah,
that.
it is,
right.
yeah.
Yeah, you get to travel. So do you live in the U.S. or do you live in
No, I actually live in Switzerland, but now I came here to the U.S. for 4 months, so I live in Kentucky. Just to visit customers and being in the same time zone more or less as the customers.
Why did you choose Kentucky?
Because actually our main representative in the US, Mr. Curtis Milton, is pretty well known in the industry. He's living there, so I chose it there to be near to him. And it's a beautiful state actually.
What city do you live in?
Frankfurt, capital.
I know it. Yeah.
So actually I live just next to the capital there. Yeah. It's nice. It's beautiful.
So we're going to talk about a lot of different things, but the first one I want to ask you is define the grid edge from your perspective, Pfiffner's perspective.
Yeah, well, I mean there are different perspectives on that, but for me the grid edge is like the grid that it is today with all the innovations, mostly like smart innovations, like smart meters and so on, that help facing the challenges that we have with the current grid, especially on the distribution side. So with all the things going on there, the grid edge needs to change a bit, needs to be innovative, needs to be modernized. And so I would say the grid edge there is all the new products, innovations, software and hardware coming into that part and help facing these challenges and overcome them.
And what is Pfiffner's role in that? What is it that you provide in that large space innovation technology?
Yeah, well, we come up with innovations like helping our customers facing these challenges. One topic is power quality, for example. So with all the things like renewable energies, solar installations on the households and on roofs, and then you have the rising demand with EVs and industry. So you have all these things coming into the grid, and the grid was not really made for that, right? So for households generating power and putting them into the distribution side, and at the same time getting or putting more power for their EVs and AC and so on. So all these things can influence the power quality. You have like transients, high frequencies, like sudden interruptions, harmonics, and we help our customers really to measure these and to identify where problems may occur and help to face these problems. Yeah.
In 2001, FERC, the NERC-FERC organization in the United States, did a study, 2001, and they looked at the cost of power quality issues in industrial and commercial America only. And in 2001, that cost was over $30 billion of losses. Yeah. Fast forward to where because they didn't anticipate as much of the grid edge, right, of renewables and all the change and electrification of transportation. So I imagine if they did that study today, that $30 billion is going to be a lot more than that. But you mentioned it, so I'm going to go there. Electrification of transportation. That in and of itself is a great thing, but it's also creating power quality issues as it goes back up into the grids. Talk a little bit about that and how Pfiffner sees electrification impacting power quality.
Yes, so actually the renewables and the electrification, there are two parts influencing that. So we just had a few years ago a customer in Austria, and the issue there was they had a huge new wind farm there, and they had substations around that, and these substations had damaged equipment due to power quality. So like big power transformers, distribution transformers, just altered really, really fast. They were noisy, so you were there and it was like brumming really loud. And so they came to us and said, hey guys, can you help us? I mean, we don't know the issue. So we installed like RC dividers there and measured power quality. And then we saw that there are like really, really high harmonics in the network due to a converter that was installed at the wind farm. So we identified that, and the interesting thing was actually, so from the wind farm it came all along the different voltage levels. So like from 345 it went down to 138, and we even found the same harmonics then on the distribution side. So it went from the generation through the transmission down to the distribution. And the same thing can occur with electrification of transportation. So if you have like a lot of EVs or electric trains or so, and they are then influencing bad power, let's say, harmonics or disturbances into the distribution side, these things may go up to the transmission line back, right? So you have then from both sides really influencing that, and if you don't identify it, then it's really hard to say where it comes from, right? So you need to like measure at all points to see where does it come from, and so where it starts and where does it end, right?
Well, you just mentioned a passion of mine, which is we've gone from a transformer world, a step down, to what I would consider to be an inverter-based world, right? And inverters don't work the same. In fact, here in California, Southern Cal Edison is finding that this inverter-based system is aging their step-down transformers at twice the rate. So all of a sudden you think you were going to get 40 years from a distribution transformer. You're not.
No, you're not. Lifetime decreases suddenly.
Why is that?
Yeah, because when you have like these really high frequencies, or maybe even let's say a DC offset in a system, all this equipment is really just made for the 60 Hertz. And if you have high frequencies or a DC offset or like sudden interruptions in the network, these equipments are not made for it, right? And they alter. And example given, as said before, if you go to a substation and you hear a really loud sound from the transformers that's not usual, then you can think of maybe there is something wrong in the network. Yeah.
Yeah. It's got to be good for your company because you're into the solution of many of those things. But I want you to talk a little bit more about specifically Pfiffner. If I buy into everything that you're saying about quality and like that, why does your solution work and why your solution?
Well, there are many ways to measure power quality, you know. A few decades ago, we wanted, or customers wanted, to measure power quality with the existing equipment. So they were like connecting a power quality measuring device to a regular CVT or instrument transformer and started measuring. You can actually measure something, but the thing that you measure is just crap, let's say. The values you get, they're just not really accurate. So you have a huge accuracy range there. So we came up with an innovation RC divider then, And this allows to measure very, very accurate up to 10 megahertz. So you can install it in a substation and connect your devices now, and you are sure that it fulfills the accuracy range throughout the frequency range. Okay. And yeah, that's pretty nice. So, and then we have, with the experience that we have from customers, as said before, from Austria or other cases, in India we are doing a lot of things, because India is having a huge, like 500 kV up to 800 kV network with very long transmission lines. And when you have that long transmission lines, they are like even more in that problematic, right? So we help with our experience to have the right equipment at the right place, and
at the right time.
At the right time, which is probably now with all the grid edge technologies and these challenges. So yeah.
Because you did India, you talked about Austria. Talk about here in the United States, your experience within U.S., Canada, your experience with a solution, almost a case study. You don't have to mention the customer, but a case study where your solution actually provided the information they needed to avoid a shutdown, to fix a problem. Have you got a good case study in mind?
Let me think about that. Yeah, we have some cases here in the US. So actually there's a customer on the East Coast that we have supplied these products to, and they have installed it in a substation. And I'm not aware if they would have had problems with altering equipment, but I'm sure they are now recognizing all these difficulties they have in the network. And for example, there is a new transmission line between Canada and the US in like northeast US.
Right. Coming
exactly.
From Quebec.
Quebec, Hydro-Quebec, yeah. And there is this transmission, and they are doing like a HVDC line there. So we are working on this project as well. Because when you have a HVDC line, especially when you connect two different power grids, or even in this case, two different countries, I mean, both countries want to know if we get the power from the other country or from another utility, you want to know if the power is in a good quality or not. So you really want to be sure about that, and then you need some certain equipment to measure that, right? And that's where Pfiffner comes into play then, yeah.
Excellent. That's really good to hear. Last question for you. Because you're an example of this. We don't have the kind of programs that you went through. Where you're working 2 days and going to school 3 days, or vice versa. But the apprenticeship programs, we are just beginning to get back to that in the United States. Getting young people to come into the industry has been very difficult. It's extremely difficult now, whether that's at the engineering level, coming out of EE schools, engineering schools, or at the trades level. And you came in through an apprenticeship program. Talk about how valuable that has been to you personally and to an industry. Obviously the Swiss have worked on it, the Austrians have done it, the Germans do it very, very well. Apprenticeship programs to solve the labor issue that it seems everybody's having.
Yeah, I mean, I'm a big fan of apprenticeship. So when I was still at school with 12, 13 years, I had to make a decision. I had the grades to go to high school.
When you were 12 or 13 years old, you had to make a decision.
Yeah, you have to make the decision. Do you go further to school? You stay in school, go like to high school, college, and university, you make maybe your bachelor's or master's degree, and then you end up being 25, 30 years old, and then you get into a job. And I said, no, I don't want that. I want to have education, that for sure, but I want to have training and experience in a real job. So then I decided to make the apprenticeship, and it's something really valuable to the person doing that, but also for the industry. Pfiffner is having like 5, 6, 7 apprentices every year in different jobs. So we have commercial, we have guys in production, electronic, and so on. And that's really nice. But you still have the opportunity after that. For example, I did then my bachelor's degree. After I did the apprenticeship, I went to a bachelor's to university to make my bachelor's. But also that, the school was in the evenings and weekends. So I managed to work 80-90% of the time. I was working. I was even able to travel to conferences and customer visits. But at the same time, I did the university, and that's something really nice because you can combine what you learn in theory and directly apply it into your job. And I think that's more valuable than having like 10-15 years of just theory, but you don't know really how to apply that afterwards. So that is really the case. That's the most important thing, and I think we should encourage young people to do the same, to make an apprenticeship, get the education at the same time, but yeah, gain experience in the real world.
On your LinkedIn profile, you have a quote by somebody.
Yeah.
Do you remember what that quote is and who it is?
I think it's Theodore Roosevelt,
Yes.
probably.
Yes.
Yeah, and the quote is that the most wonderful thing is having a job which fulfills you with pleasure and is something with like value. Yeah.
It brings worth to society. It brings
Exactly.
Worth. Yeah, that's very
And
good.
I think that's something I have. I mean, I absolutely love my job. I love the company. We are a family-owned company. We are a small team. We are really, it's like a second family at the end. So it's beautiful. I go to work every day with a smiley face because I'm looking forward to see the team there. And I mean, even during COVID, I said I don't want to be at home in a home office because then I miss my colleagues. I want to be at work, talking to them, seeing them, and it's amazing.
That's excellent. Colin, thank you so much for joining me. I appreciate it.
Thank you.
Great interview.